Alright guys, we're back for some more probability today. Again, we're talking about marginal, conditional probability. We're going to get into some independent, dependent variables and some mutually exclusive events also in this slideshow. Again, you can download this in Angel, follow along. If I'm going too fast, feel free to hit pause, go back, look over this, get into this. Some of this stuff gets a little confusing, but I'm going to try to make it as simple as I can for you today. So we'll start out with marginal probability. Marginal probability is the probability of a single event occurring without consideration for another event. Okay, marginal probability is also known as simple probability. Alright, so what is that marginal probability? The probability, here we got this chart, it's in your book on 4.5. The probability of somebody being in favor of this event happening or probability of being against. Well, the probability of being in favor doesn't really take into consideration anything else. There's 19 in favor out of 100 total things. So our total is right here. Probability of being against is 81 or against out of 100 total things. So those probabilities are not, they're simple probabilities. They don't rely on anything else. Over here, male, female, they're the same thing. They're also simple probability. They don't rely on anything else. We get into reading these. We got the probability. The in favor, the first thing that shows up here is the event whose probability is to be determined. That's what we want to determine. That event we want to determine. This little bar that's up and down is read as given. That's what's given. And the last thing, the event that has already occurred. We've already determined that they're male. So what's the probability of being in favor given male has already occurred? So what's the probability of somebody being in favor given they're a male? So that's what we're going to look at. Okay, conditional probability is the probability that an event will occur that another event has already occurred. That's what we were just talking about, what we just read about. Something else has already occurred. If A and B are two events, then conditional probability of A given B is written as follows. Probability of A given B. And it shows here, it reads probability of A given that B has already occurred. So we're going to look at this. We're going to go back to that table. We're going to refer back to that table, and we're going to compute the conditional probability of people being in favor given that they are male. All right, so we go back to the table here, and 15 people that were males were in favor of this. 45 people that were males were against this. So what we want to figure out is the probability of in favor given their males. So first thing, we got to add up all our males. We add it up and we get 60 total males. So down here, the total number of males is 60. And then we look at the number of males who are in favor. We go here, it's 15. So 15 divided by 60, or 25% of people that are males are in favor of this. So the easiest way to look at this is on a tree diagram. So our tree diagram, the first thing that we have to determine is they're male, because it's the probability they're in favor given male has already occurred. So we have to figure out their male. So we got a tree diagram, they're male, so they come up this branch right here, that's male. Now once we get up there, notice 60 out of 100 people are male. But now we get up here, now we only have 60 people in this upper branch because we took all the females out and they're in the lower branch down here. So now all we got to figure out is, are they in favor or are they against? So you put the favor on top, against on bottom. 15 are in favor out of 60 males. 45 are against out of 60 males. So when you draw these tree diagrams, you always start with what has already occurred. What do we know? We knew they're male. They come up here. Now, are they in favor? Are they against? That is conditional probability. Conditional probability is one of the things people struggle with the most. But if you break it down in a tree diagram and keep it simple, very easy to do. Alright, we get in here to mutually exclusive events. Events that cannot occur together are said to be mutually exclusive. You flip one coin, you can't flip a head and a tail at the same time, right? So that'd be a mutually exclusive event. So we're going to consider the following events for one roll of the dice. We're going to roll the dice one time. So the first thing we want to know is A is equal to an even number being observed, a 2, 4, or 6. B is an odd number being observed, a 1, 3, or 5. And then C is equal to a number less than 5 is observed. So your outcomes are 1, 2, 3, 4. So it asks us, are events A and B mutually exclusive? So even, odd numbers, are they mutually exclusive? Are events A and C mutually exclusive? So even number observed and a number less than 5 observed. So that's what we want to answer. Well, let's look at it. Even and odd, that's pretty simple, right? You can't roll an even/odd number. There's no such thing. Your odd numbers are here, your even numbers are here. There's no overlap when we draw a Venn diagram. That would mean they are mutually exclusive. Now, you come over here to the second one where it's less than 5 or an even number. Notice your 2 and your 4, which are odd even numbers, so your even numbers 2, 4, and 6 are in this circle. Your less than 5 are in this circle, the 1, 2, 3, and 4. But notice the 2 and 4 are in the overlap area because they could be less than 5 and they can be even. These are said not to be mutually exclusive because there's that overlap in your Venn diagram. Next, we're going to talk about independent variables, and there's two types of variables, again, independent and dependent. Two events are said to be independent if the occurrence of one does not affect the probability of the occurrence of the other. In other words, A and B are independent events if the probability of A given B is equal to the probability of A. Okay, so the probability of A given B is just equal to the probability of A. Or, this is separate, the probability of B given A is equal to the probability of B. Okay, so that's how you determine independent. Independent means they don't rely on each other. Dependent, they do rely on each other and they do affect the probability. So independent means we're going to get two probabilities that are equal. These are equal. Dependent, they're not going to be equal. So let's go over an example of this. We're going to go back to the 100 employees again. We're going to go back to the in favor. We're going to use that example here a couple times. Are the events female, so F, and in favor A, independent? That's what we want to figure out. First thing we've got to do is we've got to figure out the probability of being female. So go back to that chart, and we're going to look up how many were female out of 100. If you remember, it was 40 out of 100. And then we want to know the probability of in favor. All right, so first thing, event F and A will be independent if the probability of being female is equal to the probability of female given you're in favor. So we get down here, we get the probability of female is 40 out of 100. 0.4. The probability of being female given you're in favor, well, if you go back to that chart, only four of the 19 females were in favor. So your probability is 0.2105. These are different probabilities. That means these are going to be dependent events. And so if this was 0.4, the bottom one of the probability of being female and being against was 0.4, then we would have independent. But in this case, we have dependent events. Sometimes this stuff gets a little confusing when you're going through it, but really just go back to this and look. What's the probability of being female? 40 out of 100. What's the probability of being female given in favor has already occurred? So if we go all the way back, and I'm going to go back real fast to that table, see if this helps. Alright, so the thing that already occurred is the in favor already occurred right here. So there's 19 people that were in favor. The probability of being female out of that is 4 out of 19. That's how they got that. So now we look at the probability of being female. Well, that's 40 out of 100. And we want to know, are these two equal? In this case, they're not, so they're dependent events. I really hope this helps. Again, if you get stuck, give me a call or email me, and we'll work through these together. This was marginal and conditional probability, independent, dependent events, and mutually exclusive events, guys. Thanks for being here again today. Make sure you get those homework assignments submitted.